IoT Unplugged. Tune in to the Internet of Things. In the intricate landscape of IoT deployments, the concept of connectivity twins stands as a groundbreaking innovation. Whereas a digital twin is a virtual model of a physical object or system, which allows for real-time monitoring, connectivity twins take this concept further by focusing specifically on the connectivity aspects of devices. These twins not only replicate the physical and operational characteristics of IoT devices, but also their connectivity data, providing insights into network metrics, data usage, and interaction patterns with mobile networks. A concept spearheaded by BICS, connectivity twins promise to bring a lot to IoT. Yet, like with digital twins, the rollout of connectivity twins faces challenges, including the complexity of telecom acronyms and protocols, the integration of connectivity data with business processes, and the need for enterprise to understand this action and data effectively. But how can these rollout issues be overcome so IoT can reap the benefit? To discuss this further, I'm joined by Nguyen Quan, Senior Product Manager at BICS. Nguyen, thank you for joining us. Could you start by introducing yourself and sharing a bit about what BICS does?
Yeah, hi, Kristian. Happy to be here with you and to share with your audience on how connectivity providers like BICS can play a role in the IoT digital twin world. So I have more than 20 years experience in the telecommunications environment, so from management consulting to delivery of major BSS OSS transformations programs. And I spent my 10 last years at BICS, where I served as IT enterprise architect. Then I was heading the mobility solutions engineering teams. And for the last 3-4 years, I'm acting as senior product manager for IoT solutions. So I can introduce to you BICS. So basically BICS is the global network that you and many people are using every day, but without knowing it. We are enabling the global mobile connectivity of people when they're traveling abroad. Concretely, it means that BICS owns and operates a global infrastructure that interconnects all mobile operators in the world, and we are transporting them for them the signaling and the data traffic back to the home network of the subscribers. So BICS is what we call a carrier. So we have been on the market for more than 20 years. Our headquarters is in Belgium, and we are providing international connectivity solutions to mobile operators, MVNO, telecoms, or enterprises.
Okay, great. And today we're going to talk to you regarding BICS's work in the connectivity twin space. Maybe a good place to start this set of questions would be, could you explain the concept of connectivity twins and how they differentiate from the traditional digital twins in the IoT space?
Sure, Christian. So IoT customers and manufacturers, they have several options to collect data from IoT devices. Then they have to transfer all those data to IoT cloud services or enterprise applications, right? So they will get all those data, they have to process them and visualize them in a business applications for management, monitoring, and reporting purposes. And that's why they need to create a digital representations of the physical device in the cloud virtual environment. And basically, this is what we call a device twin. Now, if they start to link device twins between each other, it is what we call a digital twin. Basically, you build a relational model between your entities. So let's take an example. A car would be a digital twin composed of several device twins, like an engine with all those captures and sensors, which are linked to some transmissions, which transmit the power to the tires. So you have several entities, several device twins that combine together form a digital twin. But what enterprises is missing is really connectivity information, such as data usage and network metrics. And we believe that if we combine and merge the application data and connectivity data together, it can provide valuable information for our customers. So basically, connectivity twin is the concept of cloning virtually the SIM or eSIM in a cloud along with digital twin applications, and therefore you obtain a 360 degrees view of the device. Enterprise can then directly access to connectivity informations and insights.
Okay, so moving on, what inspired BICS to explore the development of connectivity twins? How do you envision their role in enhancing IoT connectivity? I know you've just explained a bit there, but I was wondering if you could expand on that.
Yes. So BICS being a connectivity provider, we are naturally sitting between the device and the cloud applications, right? And we look into this complex ecosystem. We ask our customer if and how they were using the connectivity data. Our findings were that majority of them had challenges to understand the connectivity data, so they could provide some actionable insight. And that integrations with the existing business processes isn't always easy because connectivity is very far away from the core expertise. So we ask ourselves three questions. First, how can we help our IoT enterprise customer to get an easier access to connectivity data? So traditionally, you know that connectivity data are left aside on the connectivity provider CMP. So CMP stands for Connectivity Management Platforms, and is basically the applications that will be able to control the connectivity. So the questions we ask ourselves is, how can we help our customer to extract value out of it? So we can help them to run more efficiently the business. So in most of the cases, our customers do not understand the complexity behind connectivity, and telecom is all about acronyms. So location update, cancel location update, RAT type, PDP create, PDP delete. It's really like Chinese for our customers. So the third question is, today, because we sit in the middle, but we are only actually helping our customer at the transport level, how can we help them to integrate easier the IoT device and the cloud applications at the application level? For example, Azure is not supporting natively UDP protocol, which is the preferred transport protocol for constrained power devices like LP1. And that's how we came up with the idea of connectivity twin.
Okay. And I know you've also touched on this, but again, if you could expand on how do connectivity twins provide a more unified view of IoT devices connectivity, and why is this comprehensive insight crucial for IoT developments as a whole?
Well, when we're thinking about launching this concept, we had four objectives in mind. First, we wanted to help enterprises that lack IoT expertise by doing the protocol conversions, right? As I just explained with UDP. Then we wanted to deliver the device data enriched with connectivity straight to the cloud applications with zero-touch integrations. How did we do that? We built some cloud connectivity solutions templates that can be loaded directly into the different cloud environments like Azure IoT Central, could be Azure IoT Hub, could be an Azure Cosmos DB, or AWS Kinesis. So we are really helping the customer to ingest more easily the connectivity data into the environment. The second objective was to bring data analytics and smart events that can be delivered in a business language so our customer can understand them and take a quick and efficient decisions into the business processes. Our third objective was to give them a 360-degree view of the device by providing an understanding of the customer operational context. So it could transform the digital twin into a holistic solutions. So they will no longer need to use two different tools to manage device and connectivities. So just imagine today that if they're only using device and digital twin without connectivity, and there is an issue with the connectivity, they need first to identify which SIM card was inserted into the device. So are they going to use the IMSI, MSSN, ICCID? There are so many keys. And then they would have to log into another platforms, look at that keys, and try to troubleshoot what was happening with the connectivity. So it's not very, I would say, practical. And the fourth objective that we had, we believe that by combining connectivity and device data sets will unlock opportunities to solve customer-specific issues. So I would like to give an example. For example, if we talk about LP1 devices, which usually run on the battery, so connectivity can help them to predict the remaining lifetimes. How they would do that? If they measure the network uptime, the PSM and eDRX availability, they can compare that against the theoretical voltage that the modem will consume. So very simple, number of times that actually the modem got power ons and that voltage. And then they can derive how much exactly the device consumes the battery.
Okay, you're talking a lot about the customers or the clients who what they can get out of this. I was wondering, could you share maybe an example where connectivity twins have significantly improved operational efficiency or troubleshooting processes for an IoT deployment?
Yes. So I would like to take troubleshooting as a good example. So troubleshooting is very broad. So it could be a simple questions as how can we help customers to identify devices who have connectivity issues at a large scale, right? Or it can be how can we predict devices who will have issues to connect in the future? And if we take one step further, how can we prevent the device to disconnect before it is even happening, right? So there are different ways to approach the troubleshooting. Now, all the connectivity data that the customer can access today, which are quite raw, would allow them to do that. So typical data set that BICS can provide or any connectivity provider can provide is, for example, the geolocations. So you know where the device is actually located, the regions, the country, the network, or even the cell ID. We are also providing the failure events, like, for example, location update failed, or if the roaming was not allowed in a specific network or country. We can provide connections events, like the radio access type that the device was connected, so 3G, 4G, 5G, LTM, and BOT, or to which network it got connected to. Or we can provide usage events, which can be very useful to detect, for example, if there was a sessions open, but without any traffic usage, right? Now, customer would have to ingest all those data to help him to troubleshoot. But unfortunately, as explained earlier, often they do not understand all those data and how to use them. So what Connectivity Twin can do for him is actually aggregate all those metrics and events, transform them, and create some triggers that we can expose to the cloud applications. So for example, instead of failure events, we would give to them the number of times that the customer got disconnected over the last 24 hours, for example, the locations, the network, and the radio access type he got connected to. So how can customer use that information in a meaningful way? So let me give an example. A truck is getting disconnected every day between 8 and 10, for example, in an area not served in LTM by one of the roaming networks. And that can be an issue for the customers. So what he could do, so the business decisions he could do if he would have that information, is to apply automatically a rule to steer for that specific truck to use an alternative roaming network between 8 and 10, although the other network is more expensive. So we are pre-shaping all those metrics for his use, and then he can just decide yes or no what he wants to do, if he wants to act on it or not.
Okay. I want to talk about your BICS's collaboration with Avnet, and I wanted to see what specific challenges the connectivity twins are addressing in that circumstance, and what benefits are they bringing?
So Avnet is selling modems equipment with embedded connectivity powered by BICS. And what they have done is develop a cloud applications on Azure called IoT Connect platform, which is basically a customized version of Azure IoT Central. And they actually propose to the customer classical device management functions. What they wanted actually to do was to include the key connectivity metrics within the applications. So the customer would not have actually to use another platforms to control the connectivity side. And on top of just showing the key metrics, they wanted to develop some actionable functions like the ability to directly block the SIM cards or steer to another network or top up the credit of a specific device straight into their business applications. The main challenge that we encountered was how we could actually help them to do that at a scalable level because they have a lot of devices. So one of the challenge was to link back the connective information, so raw data, to the right device. And for that, we use the IPs in our middleware. So outcome for AFNet was at the end, they were able to offer a simple solution to the customer, which was the IoT Connect platforms, but embedding as well connectivity metrics and functions so the customer will not have to leave the platforms to do that.
Okay, so what are some main hurdles you've encountered while you've been integrating these connectivity twins into existing IoT infrastructures, and how have you overcome them?
Well, it's a very good question, Kristian. It was not that easy, but our connectivity solutions relies on the fact that customers are using BICS not only for the connectivity infrastructure and transport, but also for the applications layer, because we would act as a middleware that will convert and structure the data set, unifies that with enriched connectivity data before we push that to the cloud applications with some templates, right? This means that existing customers who already have done that integration with the cloud, well, they need to change the routing to route their device informations now to our middleware so we can put act on the behalf, I would say. And that was sometimes a challenge to convince customers to reroute that to our box, I would say.
Okay, great. On to the next. What about sort of interoperability? How do connectivity twins interact with other IoT technologies like edge computing and AI, and how do they contribute to the ecosystem?
That's a very good question again, Christian. Thank you. So, edge computing principle is at the end to move the data processing away from the device to the network's edge. And in that sense, connectivity twin can be considered as a network edge component because we act as the middleware between the device and the cloud. When we do that, actually it's going to help our IoT enterprise customer to simplify and optimize the way they design the IoT device because we remove some complexity from their side. Now, if we talk about AI and machine learnings, it just means actually to bring even more advanced connectivity analytics to our connectivity twin, I would say, box. So an example could be anomalies detections. It's very tricky to detect anomalies at a larger scale, because for that you need an extensive data set that one individual customer cannot provide. So for that you need really a lot of data from different customers to put together so you can try to derive some meaningful, I would say, findings. And obviously the GDPR questions and all those that needs to be anonymized before you can do that. So it's quite a challenge. But at the end, I would say that edge computing and AIs are very compatible with the concept of connectivity.
Okay, and from your perspective, what role do connectivity twins play in the future scalability of IoT networks, especially considering the growth of IoT devices that are coming online?
Well, the more IoT enterprises are growing, the more they will get raw data to process. So either it's going to be device data or connectivity data. So digital twin is a must-have to structure and visualize their device data so they can run and manage more efficiently the business. Connectivity, it really depends on the use case. So it can be either contribute to the value of the business applications, like the battery predictions use case that I explained a little bit earlier, or it can help to ensure that device keeps sending the data in the most optimal way by using advanced metrics to detect upfront anomalies.
Okay. What steps should organizations take to prepare their current IoT systems for the integration of connectivity twins technology? Perhaps, you can even link back to the examples you've had in adjusting existing IoT infrastructure to handle connectivity twins.
Well, I would say that first, they need to reach the existing connectivity supplier and ask, how they can retrieve connectivity data insights, right? And there are different ways to do that. So, for example, some connectivity providers only expose APIs or data streams, but that would require enterprises to have cloud developers to ingest all those data and understand what is behind them. And then they will still have the challenge to process all those data and link back to the device data set, which can be quite, I would say, complex. So other connectivity suppliers, they're actually proposing customers to use the SDK on the device. So this will still require some development, but this time on the devices. And it can be very complex to do it and support it along the life cycle of the devices. And the third option is what we did, which was to deport that enrichment logic to the network edge. So customer will not have to bother with formatting the data into either the device or into the cloud, as we would act for them in the middle layer.
Okay, and now just looking towards the future, how might connectivity twins evolve, and what new capabilities could we expect to emerge from them, and what new insights could that maybe offer businesses who are choosing to implement connectivity twins?
Well, I would say that first, they need to reach the existing connectivity supplier and ask how they can retrieve connectivity data insights, right? And there are different ways to do that. So, for example, some connectivity providers only expose APIs or data streams, but that would require enterprises to have cloud developers to ingest all those data and understand what is behind them. And then they will still have the challenge to process all those data and link back to the device data set, which can be quite, I would say, complex. So other connectivity suppliers, they're actually proposing customers to use the SDK on the device. So this will still require some development, but this time on the devices. And it can be very complex to do it and support it along the life cycle of the devices. And the third option is what we did, which was to deport that enrichment logic to the network edge. So customer will not have to bother with formatting the data into either the device or into the cloud, as we would act for them in the middle layer.
How do connectivity twins enhance the security of IoT networks?
Well, connectivity twin is based on the SIM cards, right? We are providing to our customers SIM cards that they put into the devices. And de facto, a SIM card is a mini crypto safe place, which is actually used to establish end-to-end security from device applications to corresponding cloud server applications. So we secure the transport layer. The SIM cards can be used as well to hold the credentials that the applications will use to authenticate. So this is actually a standard that GSMA launched in 2022 called IoT Safe that could be used to remove the complexity of injecting the keys during the device manufacturing process. So with the connectivity twin, we would be able to provide dashboards that show exactly the lifetime of the certificates of each of the device, so we can renew the device on time for the customers. So they no longer have actually to manage separately the different certificates when they will expire. Now they will be able to log into the connectivity twin dashboard to look at the security and check which actually certificates needs to be renewed.
Finally, for businesses interested in adopting connectivity twins, what initial advice would you offer to ensure a smooth transition and maximize the benefits of this technology?
Well, first, we need to make sure that our customers has the connectivity foundations laid down correctly. So meaning, do they have a seamless connectivity and consistent quality of service and an access to the desired radio access technology into the countries they are operating? So good questions would be, do they have an efficient self-management portal and process to avoid that only experts can deploy and manage connectivity devices, right? So if they have those foundations, then they need to check if a connectivity twin is really needed or not for them. So they need to quantify first the operational gain by having somebody who would take care about the device protocol conversions or deliver the information in the cloud application with zero touch integrations, so they can really focus on the business applications. And lastly, they need to understand how connectivity data insight can help them to add value to the existing business applications or to help them to operate it more efficiently.
Okay, I think that's a good place to end it. Nguyen, thanks for taking the time to speak to us today.
Thank you, Kristian.
Remember to subscribe to IoT Unplugged wherever you get your podcasts. And don't forget to share with anyone you think would find it as interesting or as informative as you have. IoT Unplugged. Tune in to the Internet of Things.